Hello everyone and welcome to TMUA Simplified. In this video, I'll be discussing the first chapter of this book, and that is quadratic function. Now this is a very important chapter because in 40 questions that you'll be getting across two papers of TMUA, you will be tested on the concepts of quadratic function in at least 6 to 7 of them. So it is very important. Do it thoroughly. After the chapter, there are questions which I have compiled. Go through those questions, and at the end, there will be answers and video solution of each of those questions. Right. So let's start. Now, a quadratic function is written as y is equal to fx is equal to ax square plus bx plus c. It's a degree 2 function, or you say it's a degree 2 polynomial, right? And the degree of this function is 2. Now, first of all, we have to understand what does this represent in our xy plane, right? Knowing a function, just through equation is not sufficient. You should also be knowing the function through the graph or the curve that function, follows, right? So the graph of quadratic function depends on the coefficient of x square, which is a. So if a is greater than 0, so the graph of this will somewhat look like, right? So if I just erase it, right, it will look like a parabola, right? So if I draw the graph, it will be like this. Technically, it is called a parabola. So I'll just give it a name cup just to differentiate, because for a less than 0, it will be again a parabola, but a downward parabola. So I'll be using the term cap. So cup and cap, both are parabolas. One is upward parabola, other is downward parabola, right? Now, in this, for this curve, we have x-intercepts, which we also call roots. As the name suggests, x-intercepts are the values of x where y is 0. That means on the x-axis. So on the x-axis, y is 0. So these are basically the roots of this quadratic function, right? Rest every point on this curve, an ordered pair x comma y is just a solution of this function, right? So roots are specific values of x where y is 0, right? And or you can say roots are those values of x where the curve intersects with the x-axis, right? So this is very important. Now the next thing is, how do we calculate roots? So roots, we have we all have done that thing in our schools, and that is method of factorization. But again, there is a formula also. If the two roots are alpha or beta, then they are given by minus b plus minus under root b square minus 4ac upon 2a. So one of the root is with plus sign in between, and one of the root is with minus sign in between. So this is one result which you should always remember. Although you can factorize split the middle term and factorize, that also can be done, but this formula will be quite often used in TMUA exam, right? Now, what is sum of roots? If I say alpha plus beta, another result that you have to remember, alpha plus beta, if you see, I have two values hidden in this formula. If I take one of them and the other with a plus sign and the other with a minus sign and add both of them, so it will turn out to be minus b by a. So this is called sum of roots. And what is product of roots? Product of roots is given by c by a. These a, b, c have their meanings hidden in the equation y equal to ax square plus bx plus c. So to calculate roots, I put ax square plus bx plus c as 0. And then I get these two values. So a, b, c have their meanings. A is coefficient of x square, B is the coefficient of x, and C is the constant term in this quadratic function. So these two results are also very important, which you should remember, right? So we should know the shape of the curve, we should know how to calculate roots, we should know what is sum of roots and what is product of roots, right? So these three results are very, very important, right? Now let's move ahead, and suppose I have to calculate root of a equation x square minus 5x plus 5 equal to 0, or let's take first 6. Now this can also be done by middle term split, or we can do it directly also, that what is sum of roots here, which is 5, and what is product of roots here, which is 6. Now I'll just look for two numbers whose sum is 5 and product is 6. Sum is 5 and product is 6. So it is very easy to just, we can just think of the two numbers, right, whose sum is 5 and product is 6. So it easily gives me 2 or 3. And that is the concept behind splitting the middle term also. So we can directly calculate roots by using sum of roots and product of roots. But if our equation becomes a little complex, where it is not easy for me to have rational numbers splitting into product and sum, we have to use formula. So for this, the sum of two numbers is 5 and product of two numbers is 5. So the two numbers cannot be rational or integers, right? They have to be rational numbers, and then I have to use the formula alpha beta. So I'll say minus b is minus 5, plus minus under root b square, which is minus 5 squared is 25, minus 4ac, 4 into 5 into 1, which is 20 upon 2 into 1. So the two roots that I'm going to get will be 5 plus minus root of 5 by 2. So one of the root will be 5 plus root 5 by 2, and the other will be 5 minus root 5 by 2. So this is something which you should know, very easy, and you can easily calculate the roots, right? Let's now move on to some aspects, right, which are very, very important, and that's called nature of roots. Now, by nature of roots, here I mean roots being real or imaginary, right? In my school days, I have categorically learned that imaginary numbers are the numbers where I have to take root of a negative number, because root of negative number is not real. So root of minus 1, as I all know, is iota. So root of minus 4 will give me root of 4 into root of minus 1, which will give me 2 iota. So these are imaginary numbers, just to put things in perspective for you. And now, why nature of roots depends, why are we discussing it? Let's understand again. So the quadratic formula that I have written for you is minus b plus minus under root b square minus 4ac by 2a. Now, under the root, we have this expression. And if this expression becomes negative, then the roots will become imaginary, right? So that's why we are discussing nature of roots. So it is very, very important. So nature of roots solely depends on expression b square minus 4ac, which we can say is called discriminant. There's a name for it, and that is discriminant. So if I understand this in detail, so if I say b square minus 4ac is greater than 0, then I can say that roots are real and unequal, because I'll get two different values of the roots. And if a is greater than 0, so it will cut the x-axis at two different points. And if a is less than 0, then again it will cut the x-axis at two different points, but it will be cup and cap. But then there comes a case when b square minus 4ac is 0. Now if b square minus 4ac is 0, then the root of 0 becomes 0 only. So my roots will be minus b plus 0 by 2a and minus b minus 2a by minus b minus 0 by 2a. Both will give me a same value. So I can say roots are real and equal, to which I can say the shape of the parabola will be, it will be touching the x-axis, tangent, x-axis will be tangent to it, it will be touching and going. So this is how you should understand the graphs. And if b square minus 4ac is less than 0, so then in that case I say roots are imaginary, because inside the root I will have a negative value. In such cases, the graph will be above the x-axis for cup shaped and will be below the axis for cap shaped. Right. So this is something which is worth understanding, very, very important. There have been questions in TMUA in the past which are based on the theory of this. Right. So let's go ahead and suppose now the type of questions which you can get on this is, let me, although I've covered a lot of question in the exercise, but let me just give you one instance where, example which can test you on theory or nature of roots. Like, for example, suppose I tell you how many equations of the form ax square plus bx plus 1, and you have given you c here equal to 0, can be formed which have real roots. Real. I'm just using real. Real includes both unequal and equal roots, right? Both the cases. So have real root, which have real roots, where a and b belongs to a set of 1, 2, 3, and 4. Now this is something where you have to improvise a bit. Reason being, the values of a and b are not fixed; they are, variables, right? But they can take any of the values among 1, 2, 3, or 4. And a and b can be distinct as well as same, because nothing is being mentioned. So, but the key word here is real. So the moment I hear real or imaginary in a question, so my first instinct will be to think about the discriminant. So I know if roots are real, so the discriminant is greater than or equal to 0. I know the value of c is 1, so b square minus 4a, or we can say b square should be greater than equal to 4a. Now I'll just list down the possibilities of the cases where b square is greater than 4a. So b square, possible values of b square is 1 square 1, 2 square 4, 3 square 9, 4 square 16. And those of 4a are 4 into 1 4, 4 into 2 8, 4 into 3 12, 4 into 4 16. And I need to follow this condition or this condition as I've written. So b square should be greater than or equal to 4a. Now 1 is neither equal to or greater than any of these 4. So there is no case. So taking a as 1 or a square as 1, I have no case in which the roots will be real. Then comes the second, 4. Now 4 is at least equal to 4. So there is one more case. But for 9, there are two cases, 4 and 8. So when a is 3, I have two cases for b1 and b2. For 4a to be, sorry, for b to be 3, I can take a as 1 or 2. And for b being 4, so b square will be 16, I can take all the 4 values. So it gives me 7. So I can have 7 such equations which have real roots. So these are the type of applications you will be getting based on real and imaginary. This is just one of the cases. There can be many cases. So I've covered a lot of questions like this in the exercise which will follow this chapter in the book. Let's go through that. Now the next thing is equations reducible to quadratic. Now sometimes equations are not directly quadratic, but we have to convert them into a quadratic. Like for example, suppose I say x to the power 2 by 3 minus 5x to the power 1 by 3 plus 6, if I say, is equal to 0. And I have to solve such an equation which have powers which are not integers and powers in fraction. Now, if I solve it through normal method, it might take a lot of time, right? But I can see that if this is some value, then this is a square of it. So it'll just replace, suppose, this by some other value variable y. So x to the power 2 by 3 will give me y square, squaring both sides. So y square minus 5y plus 6 equal to 0 again will give me roots 2 or 3, as we can find out. Sum of roots is minus b by a, so it will give me 5. Product of roots is c by a, which will give me 6. So 2 or 3. But these are not the, there will be option which will give you 2 plus 3, 5. No, that's not the right answer. Suppose, see, because the question says, okay, suppose this question says find the sum of the values of x for this equation. Now these are the values of y, not of x. So if suppose this is the question, sum of the values of x, so 2 plus 3, 5 will not be the answer, because x to the power 1 by 3 is y. So if I put it 2 and cubing both sides, x will give me 8. And if I put x to the power 1 by 3 as 3, then cubic both sides will give me 27. So the sum of the values of x will not be 5, because that is for y. It will be, for x, it will be 8 plus 27, which is 35. So these kind of equations are called equations reducible to quadratic, right? I can take another example. Suppose I have an equation which says that 4 to the power x minus 6 into 2 to the power x, right, plus 8 equal to 0. Now this is in exponent form, but again, solving this directly will be a problem. And suppose they say find the sum of the values of x, or product also they can ask. Now I can see if 2 to the power x is some variable, say y, then 4 to the power x is nothing. Or I can, if I square both sides, I'm gonna get 2 to the power 2x equal to y square, which is 2 square is 4. 4 to the power x will be y squared. Right, so it becomes a quadratic. So again, it's an equation reducible to quadratic. 6y plus 8 equal to 0. Now the sum of root is 6 and the product is 8. Sum of root is 6 and product is 8. So the value will be of the roots will be 2 and 4. Value will be 2 or 4. Right, but these are again values of y, and I have to find the values of x. So I know 2 to the power x is y. So if I put 2 to the power x as 2, I'm going to get x as 1. And if I put 2 to the power x as 4, so which will give me x as, because I can write 4 as 2 square, so x will be 2. So sum of the values, the answer will be 3. So 3 is the right answer. So these are all equations reducible to quadratic, and in TMUA for the last so many years, we have papers available on the TMUA site from 2016 onwards. So if you look at all those papers, you're going to find this type of a question at least 4 to 5 times. So it's very, very important, right? Equations reducible to quadratic, right? Let's move on to the next thing, and that is vertex of a parabola. What is vertex of a parabola? For a cup shape, it will be the downmost point, and this is the upmost, the maximum point. Now, this is vertex of a parabola. Now, vertex of a parabola, right, is the coordinates of this is what I need to worry about, because there have been questions which are based on this. Now, always remember, if this roots is alpha, then this is beta. So the x coordinate of the vertex for both of them, suppose this is alpha, beta, in both the cases will be the average of the roots. That is alpha plus beta divided by 2. And I know what is alpha plus beta. Alpha plus beta is minus b by a. So it becomes minus b by 2a. So the x coordinate of the vertex is minus b by 2a. Right? And if I have this function y is equal to fx equal to ax square plus bx plus c, so the y coordinate I can find by putting this value in this function very easily, right? So this is what I need to remember. So suppose I have to find a vertex of a parabola y is equal to fx equal to x square minus 10x minus 11. So I know that the x coordinate of the vertex will be minus b by 2a. Average of the roots, which is minus b by 2a, sum of roots divided by 2. So it's going to give me minus 10 upon a is 1, so 2 into 1, which gives me 5. This is the x coordinate of the vertex. How will I find the y coordinate? I'll just put the value 5 here, and I'm going to get 25 minus 50 minus 11, which will give me minus 61 minus 36. So the vertex of the parabolas is 5 comma minus 36. And similarly, I can find it for the other curve also if it is a cap-shaped curve where a is less than 0. For both of them, right? And I can also say this is the minimum value of this y. Y minimum is minus 36. In this case, it is a cup shape, and for cap shape, the same value will be the maximum. Same process, basically. Is this clear? Right? So this is how we solve or we find the vertex of a parabola. Now, after this vertex of a parabola, there is another interesting thing which we need to understand. If I have a function y equal to fx is equal to ax square plus bx plus c, and suppose I know the vertex of a parabola, and suppose they say this is 3 comma minus 3, right? 3 comma minus 3, this is the vertex of a parabola, and suppose they also say that f of 7 is equal to f of k. So what is the value of k? Now this is vertex of a parabola. The line passing through vertex parabola is a line of symmetry whose equation is x equal to 3. Now when it's a line of symmetry, so I can see that f of 7 means the value of a function or of y at x equal to 7, and f of k means the value of y at x equal to k. So I have two values which are equal. So I can say definitely one will be on the right of the vertex line and the other will be line of symmetry. One on the right of the line of symmetry and one on the left of the line of symmetry. And the line of symmetry is x equal to 3. Now if I look at 7, 7 is 4 to the right of 3. This is 4 units to the right of 3. So definitely k will be 4 units to the left of 3. 4 units to the left of 3 will give me 3 minus 4, which is minus 1. So k is minus 1. So I can solve such problem very easily through line of symmetry. I do not necessarily have to form the equations and then solve it. Right. Chalo, next. Now the next thing is intersection of a line with parabola. Now, intersection of a line with parabola, by this I mean, suppose I have a parabola, so I can have a line like this. So I have an equation of a quadratic equation or a degree 2 equation and a linear equation, and I can have this case and I have this case. So line can intersect the parabola at 2 points or touch the parabola tangent to it and may not be touching or cutting the parabola, right? So in such case, suppose I have a equation like suppose we have a equation y is equal to, right, any equation ax square. Suppose I just tell you the process first, and I have an equation of a line this, right? So if I say that this line cuts the parabola at 2 points, So 2 points of intersection are there. So at intersection points, the coordinates x and y are both same for both the curves or the lines. So I can equate the y values to find the point of intersection, and in this endeavor, this becomes a quadratic equation, right? Say this is C1 and this is C2. So I say this is C1, this is C2, equal to C1 plus C1 minus C2 equal to 0. This is the process I'm going to tell you, but with numbers it will look very much simpler. With variables it is looking a little cumbersome, but with numbers it will be much easier. So now, if it is cutting the parabola at 2 points, so that means this equation will have two roots, because it becomes a quadrate. It has become a quadratic, and it will have two roots when b square minus 4ac is greater than 0. Similarly, if it would have said that it touches the parabola, so I would have put equal to 0 to solve for range of values of whatever unknown is there, and b square minus 4ac less than 0 for if the line is not touching or cutting the curve, that is quadratic. So this is how we go about solving the problems which are based on intersection of a line with a parabola, right? So this is something which is very important. Again, a part of TMUA, which is very important. Every year or every alternate year, you get a question on such a concept, which is, that's why it is very important, right? Let's move on to the next thing now. Let's move on to quadratic and some higher inequalities. Now, when I say quadratic inequality, so I have ax square plus bx plus c greater than 0, ax square plus bx plus c greater than equal to 0, ax square plus bx plus c less than 0, ax square plus bx plus c greater than equal to, sorry, less than equal to 0. Equality can also be there. These type of inequalities are there for quadratic. Now, there are rules, thumb rules to solve them, but first of all, let's understand what is the meaning of such an inequality, because a quadratic function is always y in terms of x. So if I have a quadratic function which is cup shaped and I say that this is greater than 0, so greater than 0 I means y greater than 0, and I know y will always be greater than 0 above the x-axis. So for this I will look for the part of the curve which is above the x-axis, which is here or here. So if this root is say alpha and this root is beta, so my solution becomes that x will be greater than beta or x less than alpha. And if this equality is there, this case, then I will put a equality here also, right? So this is what I'm gonna do, right? So this is the case when we have greater than or greater than equal to for a cup-shaped curve. And if we have less than 0, so less than 0 we can very well see it is y less than 0. So y is less than 0 below the x-axis. So below the x-axis, I have my solution of x, which is from alpha to beta or between alpha and beta. So if this is the case, I'll say x greater than alpha less than beta. And if this is the case, I'll say inclusive from alpha to beta. So this is how we solve a quadratic inequality, which is very important for you to understand through curve. Now, we can also make a thumb rule for it, that if we have the roots, say alpha and beta, so if it is a cup shaped curve, on the rightmost part of the line or of the number line, the expression will be positive, between alpha and beta negative, and positive. This is curve only given on a number line, as you can see. But some people then say, what if it is cap shape? So the nature will be totally opposite. So it will be alpha beta starting with minus and plus and minus. The nature will be different for a less than 0. Roots will be same, but the nature will be different, because wherever the expression is positive for a cup shape, there it will be negative for the cap shape. As you can see, if it is this cup shape, this is the corresponding cap shape, right? So wherever cup shaped is positive, cap shaped is negative. Cap shaped is positive for cup shaped negative, and vice versa. So I hope you have understood it through curves, right, which is very important, right? So this is how we solve a quadratic inequality, right? Okay, now let's test whatever we have studied in inequality, quadratic inequality, through questions. Like for example, suppose I have x square minus 5x plus 6 less than 0. So I know it's a cup shaped curve, and for this first I'll calculate the roots. Roots are pretty clear, they are 2 or 3. So here it will be positive, negative, positive through the curve only, because if I make a curve 2 comma 3, so it's positive, negative, positive. So I'm looking for less than 0 means expression being negative, so answer will be between 2 or 3. Here it is negative. So very easily I can understand the rule and solve it. But if I have a cap shape like minus x square plus 10x plus 11 is less than 0, right? So either I go by the opposite rule, that the roots of this are minus 1 and 11, which I can pretty easily calculate, right? So the rule is minus plus minus. Now for less than 0 negative, the answer will be x greater than 11 or x less than minus 1. This is what I can do. But rather than remembering two different rules, I would advise to understand it through the rule of inequality. And the rule of inequality says if you multiply an inequality by a negative number or divide an inequality by a negative number, the sign of inequality changes. Why? For a simple reason, if 3 is greater than 2, then minus 3 is less than minus 2. So on multiplying an inequality by a negative number, the sign of inequality changes. So rather than remembering a different rule, I can multiply this by minus 1. So I'm going to get x square minus 10x minus 11 greater than 0. It will give me the same roots, minus 1 and 11. But now I'll be looking for, and rule is same now, plus minus plus, because I've made it cup shaped. And I'm looking for greater than 0. Greater than 0, the answer will be still be same, x greater than 11 or x less than minus 1. So this is how we can solve inequalities for cup shaped and cap shaped, or a quadratic in general, right? So that's all for today, right? In this chapter, I'll bring you the next chapter at the end of the chapters, right? So till then, take care. Have a nice day.